Hello friends. So today we will take up a case. Infinite slope made of C5 soil. So let's say this is the slope which is made of C5 soil, and the slope angle as usual is going to be beta. So slope angle no change, beta, and the slip circle, the failure surface is going to be inclined like this, and the slice ABCD, right? And therefore, we can find out sigma V, we can find out sigma N. Let's say now the water table for this C5 soil is along the slope. So, water table is along the slope, and let's say there is seepage also. Seepage parallel to the slope. For this condition, let's find out the effective vertical stress and effective normal stress, and the tangential force also. So here, quite simple, you know it, that the effective vertical stress will be how much? If you know, it is going to be the water table is up to here. So gamma saturated, that is the unit weight of this slice, and let's say the height is h. So multiply it by h minus, because the water table is there, the pore water pressure gamma w into h must be directed into cos beta. So into cos beta. So finally this will be gamma prime h cos beta. So sigma v prime is known to you. Therefore, sigma n prime, this normal component sigma n prime is therefore equal to gamma prime h cos beta becomes cos square beta. Now, the tangential component tau will be equal to, here this mass is saturated, therefore this will be equal to gamma saturated h sin beta cos beta. So this becomes saturated mass, the shearing stress is going to be equal to this. Now, friends, tau m, this depends upon Cm prime, that is the mobilized cohesion, plus it also depends upon sigma n prime, right, into tan phi mobilized prime. This is the expression. Or tau m is gamma saturated h sin beta cos beta must be equal to Cm prime plus sigma n prime is here as gamma prime h cos square beta into tan phi m prime. So therefore, we can get Cm prime upon gamma saturated into H must be equal to H sine this sine beta cos beta minus gamma prime upon gamma saturated into cos square beta into tan phi m prime. This is the simplification, and this is called the stability number. So, stability number Ns is Cm prime divided by gamma saturated into H for this particular case for C5 soil when water table is along the slope and seepage is parallel to the slope. Now, you know the factor of safety for cohesion is C prime upon the mobilized cohesion. What is the shearing strength of the ground? Is C prime divided by mobilized cohesion. So, this implies that the Cm prime equal to C prime divided by factor of safety with respect to cohesion. So, this implies that Ns, that is the stability number, equal to C prime divided by Fc into H into gamma saturated. This is another expression for stability number. Therefore, you know that Fc is also the factor of safety with respect to cohesion, where this is the ratio of the critical height of any slope divided by the actual height. That is the factor of safety. Therefore, this implies that Fc into H equal to the critical height, and therefore, the stability number can also be written as C prime upon Fc into H can be written as critical height. So, gamma saturated into H critical. Now, if the stability number is, you can calculate it. If the critical height, let's say you have calculated it something like 15 point some meter, 15.3 or so. So, this is known to you. Gamma saturated you had taken as, let's say, 20. This was 50 kilopascal. So, you can calculate the stability number, 50 divided by this quantity, where 15.3 multiplied by 20. So, you can find out the stability number here. So, friends, the stability number can easily be calculated. Or the critical height can also be, if the stability number is known to you, then you can find out the critical height for the given data. So, these expressions are going to be quite useful for all of you to calculate the critical height, to calculate the stability number, and so on and so forth. So, these expressions, so many forms. One form, Ns equal to Cm divided by gamma sat into H, C prime divided by FCH gamma sat, C prime divided by gamma sat into H critical. So, please do remember these forms. The original form is this one for this particular case. So friends, you can do it very easily. There is no problem. And the if it is completely submerged, then you can replace this gamma saturated by gamma prime. Let's say the water table is something above the slope, then you replace ns equal to cm prime divided by gamma prime into h, because it is completely underwater, submerged. So not fully saturated like this, and pore water pressure exists. Here, in this condition, it is fully saturated, and the pore water pressure exists, right? But if there is the condition that the water table is somewhere here, not here, but it is here, then it is going to be completely submerged. Slope is completely submerged, and therefore this can be replaced as gamma prime for submerged case. Otherwise, it should be gamma saturated into H. Now, how to find out the factor of safety? So, it's quite simple. You know everything over here. So, the factor of safety, as you know, can be calculated. The factor of safety, friends, is for infinite slope is going to be tau f, that is the shearing resistance of this along the failure surface at a depth h, divided by tau mobilized. So, what is tau f? It is c prime, as you know, plus sigma n prime into tan phi m prime. This is the value of tau f divided by what is tau mobilized? It is already calculated. So, gamma saturated h sin beta cos beta, and you can further simplify it, or factor of safety f can be written as c prime plus sigma n prime. You can take it as gamma prime into h cos square beta, right, into tan phi m prime into tan phi m prime divided by tan phi, not phi m, but this will be tan phi prime. Okay. So, this sigma n prime equal to gamma prime h cos square beta c prime sigma n prime into tan phi prime. So, that is tau f. And what is tau mobilized? Is here gamma saturated into h sin beta into cos beta. So, you can simplify it as you wish. You can make it more simplify further. Now, if factor of safety becomes 1, when the factor of safety tends to 1, h equal to h critical. So, for gamma sat, therefore, gamma sat multiplied by h critical sin beta cos beta equal to c prime plus gamma prime into h critical into cos squared beta into tan phi prime, right? So this can be here, and therefore not only the factor of safety, but you can also find out the critical height this way also. One way is to find out from a stability number. You can find out the critical height from a stability number, or if you know the critical height, you can find out the stability number, or else equating factor of safety to 1, H becomes H critical, and therefore here also you can simplify it and get the value of H critical. So friends, the things are going to be quite here. The value of therefore C prime, if you divide it by gamma sat H critical, then you get a different form over here. So you can just make all sort of calculations over here, and you can find out the critical height, etc., in this form also. So I hope I have been able to uh, explain to you most of the things in a particular format and with all clarity. So this will help you in further understanding and solving the problems. So with this, I've been able to take, take up all the cases of infinite slope made of C phi psi. In my next video, I will talk about the finite slope. So finite slope, you know that failure surface is going to be different here in finite slope. So Swedish slip circle method I will explain to you in my next video. Thank you very much.